मेरी स्क्रीन नजर आ रही है?
हाँ जी, स्लैक नजर आ रहा
तनवीर आपने स्टार्ट ब्रॉडकास्ट कर दिया है?
स्टॉप कर दूं क्या? ब्रॉडकास्ट का ऑप्शन आया था।
सॉरी, अब क्या मुझे समझ नहीं आई, आप क्या कह रहे हैं?
ब्रॉडकास्ट का मुझे पॉपअप आया था।
नहीं, वो हमने अभी नहीं करना, वो जब अटेंडेंस ज्वाइन कर लेंगे उसके बाद करना है।
अच्छा, तो मैं यहाँ पे क्या करूँ अभी?
एक सेकेंड मुझे देखने में।
रिकॉर्डिंग स्टॉप कर देता हूँ।
Hello everyone, I hope you are all doing well and thank you for joining us today. Our topic for today's session is Kubernetes Operator Local Deployment Development with Tilt, which will be presented by Tanveer Alam and Munib Ijaz. Tanveer is our senior software engineer and a team lead here at Stakater, and Munib is also our software engineer who works on the infrastructure and automation. At the end of the webinar, we will also have a short question and answer session. So if you have any questions, please feel free to ask our presenters. And I hope you all have a great time. We'll just wait for a couple more minutes for the attendees to join us. Thank you. Tanveer, I think we can begin the presentation now.
Sure, Sanya. Thank you. Hello, everyone. Good afternoon and good morning. Today in this webinar, before starting, can you guys, Sanya, is my voice audible? If I'm audible, just give me a thumbs up or anything.
Yeah, you are audible.
Yeah, thank you. So in this webinar, we'll discuss some of the common challenges that we face while developing operators, and we consider that anyone who has joined the webinar would be familiar with what an operator is in Kubernetes world. and they are doing development on Kubernetes operator or controller using either operator SDK or kubebuilder or any other framework of their choice. But as this whole technology stack requires some additional dependencies apart from just building that operator binary. We usually, in our local environment, we usually run our binary, but after that, to test that whole flow, we kind of rely on some other tools such as Helm to deploy this whole operator on the cluster. And then that is a secondary effort that we have to put once we test our thing on the local environment. So for example, dependencies such as if we need cert manager or if you are building an operator that needs a custom resource of any other operator, as an example, we kind of to manage that either using shell script or any other way in our local environment. Or there are some scenarios which can't be even covered when we run it in our local environment. So the best scenario would be like if we could deploy the whole package all together in such a sense that our operator is running in a pod and all the dependencies are deployed with it in our development environment. So for such scenario, Tilt is already being used as a development tool for microservices, and developing operator is not much of a different because eventually it gets deployed in a pod. So we can use Tilt in the development lifecycle of operator as well. So before getting into depth about how we can use Tilt as a development tool for operator, we'll try to understand basic concepts around Tilt. So in Tilt, you kind of manage resources, and resources is the term that Tilt uses itself. So anything that could be deployed by Tilt, they call it resource. So a resource could be a Kubernetes manifest, a Docker image, a command that you want to run on your host machine, any other file dependencies that you would like to watch, or any other Tilt extensions that you will be using in the Tilt file. The syntax of Tiltfile is very similar to Python because they use Starlac, which is a dialect of Python. So all the basic, not all, I would say that all the basic scripting thing that you could do in Python, you could do it here. So you will have if conditions, looping, and functions that can be implemented in a Tilt file. And the way Tilt work is like we create a Tilt file which kind of act as a configuration file, and there is a Tilt engine running behind it which watches the Tilt file, and any functions that you describe in the Tilt file that gets passed by the Tilt engine, and Tilt engine knows how to provision that particular resource using their internal method. So we can start with the demo. In this demo, we'll just take a example of basic Mcache operator that Operator SDK provides by default. We'll follow the same steps that has been mentioned in this tutorial by Operator SDK. We'll start creating this project. And we'll first initialize the project here. This part we'll do it manually. And now it's saying that we can create a new API. We'll do that part, and then we'll start using the tilt. We'll start building the tilt configuration. Now what we can do is we can start with tilt up command, and what the tilt up command will do is it will look for a tilt file, and if that tilt file is not present, it will ask if it can create a default tilt file for you. So we'll say yes. Just 1 second. Yeah, so this is the that's weird. Okay. So it had created the default tilt file, and in this tilt file they have given some example of print statement and other methods of tilt. We'll just get rid of this, and the first thing what we'll do is we will so a tilt file, whenever we do a tilt up, it always looks for a resource. So if we jump back to so now it will be complaining that there are no resources found. So the first thing we need to do is create a resource, tilt resource. So as a starting point, we'll just start with some metadata that we can print on tilt file. So here in tilt, you have this default tilt configuration, which kind of gives you a way to run a set of commands whenever you do tilt up. So like these set of commands will only be executed when you do tilt up, or when your tilt file gets re-triggered by the tilt engine. So here what we are doing is we are just printing a set of details around what is the current context, which version of Go we are using, current namespace, etc. And the same way we have the tilt subcommand for up, we have the subcommand for down, meaning that whenever we'll do tilt down, we can take some a set of actions like cleanup and etc. in that way. So now you can see it's printing all this metadata, but it's still complaining that no resources found. So the next thing we need to do is we need a cluster. So for this demo, we can use a kind cluster, and we also need an image registry where Tilt will continuously build and push new images while we do the local changes. For that also, we will use kind image registry. That is very handy tool where you can have both the kind cluster as well as the local image registry with you for your development environment. But it's not mandatory. You can use any remote cluster and any remote image registry. You just have to point out to the right context, and Tilt will just use that for your local development part. So we'll use this script to create the kind cluster as well as the local image registry. And in this so in this script, what it's doing is it's first starting the kind registry as a container, and it is running it on the localhost on 5000 port. And after that, it's creating the cluster, and it's telling each node that to use this image registry as a default image registry. And what we will do is in this script, we'll add one small condition because this file would be watched by Tilt. So what we can do is we can add just one condition that anytime it gets re-triggered, it will just check if that cluster is already there. Then if it is there, it will just exit and not try to recreate it again. And we'll just echo something to indicate that the execution of this script is done. Now, the next thing we'll do is we can execute this script locally, but what we'll do is we will trigger this from our Tilt file. So there is a function called local resource in Tilt, and using local resource, you can run any of the local commands on your host machine. So it could be a command or a script, or you can even use kubectl apply. So the local resource, the Tilt continuously watches the local resource, and there are ways to provide dependencies, meaning that anytime you have a dependency on a file, then anytime there is a change in that file, Tilt engine will re-trigger this local resource function. But in this case, it will just provision the kind cluster for us. So here we can see that it created. So on the left side, what we are seeing is resources, Tilt resources. So it created a new resource by name create kind cluster. And the minute we added this function in the Tilt file, the Tilt engine got re-triggered because we added a new line in the Tilt file. So you don't have to re-trigger Tilt again and again. Anytime you make a change in this Tilt file, the Tilt engine re-executes the whole Tilt file again. And it doesn't execute in parallel. So like if you have multiple functions mentioned below in the same file, it will call it sequentially. So now the cluster creation is done. Now the next thing we'll do is we'll create the memcache CR, the sample CR that is present in this example. Now the next thing it's asking is to run make manifest, and we need to run make manifest make generate to update the deep copy file and all the CRDs in the CRD folder under config folder. So that step we need to do manually, but instead of doing it manually, what we will do is we will add another tilt function in our tilt file. And what this specific function will do is it will run make generate manifest and install. We need the install command so that after the CRD has been updated, whenever we make change in our APIs, the install command will apply those changes on the cluster. So when I added this line, if we see the tilt side, it has re-triggered it, this function, and now we can see in our cluster that there would be a CRD for memcache. Now, one challenge with this command right now is like, okay, whenever right now we added this function, so that's why it got re-triggered. But in case if I make any change in the API, in the spec of this memcache CR, it should watch this change and it should re-trigger those to update the CRD and apply it on the cluster. But because in the tilt file we haven't mentioned any dependency here, even after changing the API file, it won't get reflected on the cluster. So we'll give it a try on that side first. So we'll add this specific field size in memcache spec. Now, after updating this file, we would expect tilt to watch this change and apply it, generate the new CRD and apply it on the cluster. But if we'll see, it's still showing foo as the field of this CR, but we have changed it to size. So that is the reason behind is that the local resource function, this one, is not watching this specific file or the specific folder of API. So what we can do is we can add dependency under this. We can add another function which will watch this specific folder, meaning that anytime there is a change in any of the file within API folder, it will run these commands for us. And in the ignore section, we are saying that ignore if there is change in any of the deep copy file. But apart from that, anytime there is a change within this folder, run these three commands. So now what we can do is we can add this field, container port, and if we'll see tilt, it has re-triggered it. The watch APIs has applied it again, and we can confirm it by checking the CR again. So we have size and we have container port. Both the fields are populated. So this way, like it becomes very handy that you don't have to remember that anytime you make a change in your API files, you have to re-trigger those commands to reflect those changes on the cluster. So that is one really helpful thing. Now, what we will do is we will add this condition as well. In the status, you can see we have conditions. So it's really handy. It's really helpful at the time of development when we are doing a dynamic change. And now what we can do is the next step we want to do is run this operator on the client cluster and not locally. So for that, we would need an image, and we would have to deploy the whole configuration. This whole deployment part we need to do that. We eventually do it via like if there was no tilt and we need to deploy this whole as a bundle, then there are like possibly two approach. One is generate a Helm chart, and the other thing is you can generate a bundle and you can use OLM to deploy that part. But that is in practically it's really irritating if you have to do that again and again to just verify if everything is running properly altogether. So in Tilt, what you can do is you can not only just deploy the image in a pod, but you can deploy this whole configuration on the cluster and verify that all the components are working fine altogether. So the next thing we'll do is we'll try to build the binary for this operator. And for that, we can use, again, the local resource command, in which we'll mention the go build command, which will build the binary. And it will build the binary and it will store it in this folder. So the reason we are doing it locally is that we don't want to increase the build time. Like if we don't do it, if we don't build this image locally, and if you use the Docker file, then the time it will take to build that image would be more than it requires to do it on locally. So that's why we are doing this function locally. And once the binary is generated under bin folder, what we will do is we will tell Tilt to replace this image inside the pod that is running the operator. So the next thing that we'll do is we'll try to build this, we'll try to build and push this change into an image. And for that, we'll use Docker build with restart extension. So by default, Tilt comes up with Docker build command, but the Docker build command doesn't re-executes or restarts the binary. So there is an extension called Docker build with restart, and what it will do is whenever there is a change or whenever there is a new binary available, it will first it will replace that file and it will restart that binary. So that becomes so languages that has that are not scripting language that needs a restart. In that case, you can use this extension. And to use extension, so in Tilt, extensions are kind of a way to import other Tilt file. So like Docker build with restart is nothing but a different Tilt file with a set of Tilt resources. So anytime you want to use a Tilt resource, you will have to use this load command, which is similar to either import in other languages, you can say. So we are saying that, okay, import this function from this extension, restart process. Now, one more thing that Tilt has extension with VS Code, and it becomes really handy to see all the syntax error and auto completion, etc. So you can use the Tilt extension for writing the Tilt file code. So now it's complaining that tilt.docker file is not there. So we could use the existing Docker file, but it is like multi-stage Docker file, which will take a lot of time. So what we will do is we will create another Docker file, and in that we will just mention that we just need to copy the binary and start the manager. Start the entry point would be manager. So we'll just copy the binary there and just start this command. So in this so all we are saying that use Alpine as a base image. One more thing with Tilt is that it needs base image which has touch support of touch command. So the default Docker file that comes up with Operator SDK has is not supported. So that's one thing to consider whenever we are using a Docker file with Tilt. It should have the base image that has at least touch command, and there are some other dependencies, so that needs to be verified. So if you're using Tilt with your Docker file and if it fails, then you will have to look the base image that you're using is supported by a Tilt or not. So now we have mentioned the Docker file that this Docker build with restart needs here. So here the parameters are, the first one is the image name. The second one is the context meaning at which location this image needs to be built. This is the Docker file that needs to be used. Entry point is something that takes precedence over the default entry point or command mentioned in the Docker file. So any entry point you mention it here would be replaced by the default entry point or command in the Docker file. And in only you are saying that only trigger this command whenever there is a change under this folder. So the manager binary is getting generated in this folder. So anytime there is a new binary available, this command will rebuild the image, and the live update thing kind of tells like what action needs to be done by Tilt on the container side. So here we are saying that resync this image and restart it. So on the container, it will resync this binary without restarting that container. So it will just replace that binary and retrigger this command. So in our Tilt, we can see that so manager is so we can see that manager binary got generated, and in Tilt file, yeah, now it's complaining that it's not generating or it's not triggering the build because we haven't specified how that image would be deployed. So they are saying that there needs a way. One more thing with Tilt is that Tilt by itself internally does grouping of resources, meaning that if you have a function like Docker build, then it knows that after building it needs to be deployed somewhere. So if you haven't mentioned how that would be deployed, then it will ignore provisioning this resource as well. So right now you can see that it's complaining that because it doesn't know how to deploy this image, it's not building that image. So to do that, what we will do is we can either use make deploy command directly, but we need to do some alteration. So what we will do is we'll use customize for two things. One is like to you can use any other image that you want. You can give any other. So the image needs we need here the image name and the registry name with it. Right now we are using localhost, that's why we don't need to provide that. So we will use customize and edit that image into our configuration. If you don't want to edit your configuration, then you can edit the image at runtime in your deployments. that I will explain it later. And the next thing we'll do is we will use tilt's YAML function that knows how to deploy the Kubernetes manifest files. So the local command in tilt, it returns a blob, and blob is like a file or a binary file. So the way tilt understands whether it's a command or a file is like they have two supported data type. One is blob and one is string. So this thing, it's this command tilt understand like takes it as a string data type, but whenever it needs a file type of data on which it needs to do some provisioning, it uses the blob data type. So you can see the local command here, what it will do is it will return the blob. So this command will return the whole set of manifests that we want to apply. And we are getting this into this variable, and using k8s YAML, we are applying that on the cluster. One issue with tilt is that if you create a cluster as a part of tilt, then it fails to recognize it. So sadly, we have to stop and start again for tilt to connect with that cluster. So I've just so this check that we need here, because of this this resource was failing, I will retrigger it, and now it's success because now we have added the check that if the cluster is there, it will just print this message and ignore the installation of that cluster. Now it's complaining that no bin. So here, like I have build the image in bin directory. You can use any other directory because the bin directory is part of Docker ignore. So that's why it's ignoring it. Either you can comment this out or you can just use any other folder in your scenario. So now, so one thing, like the minute I've changed, commented out Docker ignore, it tried by itself to rebuild it again. Now it's trying to, the build is done. Now it's trying to deploy that on the kind cluster. And now you can see that it's complaining that the pod that we are running is can't be run as a root, and that's why it's failing to run that pod. So what we can do is, because it's a developing environment, we can ignore that. And the way we can do is like we can just set run as root to false, and without making any change into our configuration file. So that is a really handy thing that Tilt provides. So what we are doing here is, because at this stage we got the blob, and here we are decoding the blob into objects. And this way, like if anyone is familiar with Python, they will find it very similar syntax. What we are doing is we are iterating through all the objects that are nothing but the YAML manifest. And we are saying that if the kind is deployment and if it is memcached operator controller manager deployment, then set run as non-root to false. And you can do any customization here. For example, if you don't want to use this image, if you have any other image, you can change the image at runtime. If you want to add any environment variable, anything, any alteration that you want to do just for development without affecting your config folder, then you can do at this stage. One thing with the Tiltfile is that anytime you mention a dependency here, and those dependencies are watched and that gets re-triggered. But this current code block is not watching any specific resource. That's why whenever we make any change here, it doesn't get sometimes reflected. So we have to manually trigger it. So Tilt has 3 ways of getting events. One is whenever you make a change in Tiltfile, that generates event. The second way of generating event is using the dependency section. That is this one. And the third one is the manual triggering part, where you can manually trigger a specific resource. So right now I've manually triggered this specific resource, which is trying to redeploy the operator again. Right. So it's saying it started. So the controller is started. Now, the next thing we'll do is we'll try to do some change in the controller and see if that gets reflected. The change we can do is we can just use this small block, and all it is doing is it's just checking, it's trying to get the memcached object in the controller. So the minute I change it here, it will try to redeploy it again. So right now it's saying that, okay, there is no package by API errors. So we can see that would also reflect in our tilt. Yeah, at the build stage is saying that it has this error. So the minute we will update it, import it in our controller, it will fix it by itself. It will try to rebuild it again, and it will redeploy it again. So it's the build manager got triggered, and that has triggered the deployment again. For the demo sake, I will just off the leader election because it takes some time. And what we will do is here we will print some data around the object that we have received. So it's time to redeploy it again. Now, what we will do is we'll try to deploy one of the samples here for memcached object, and that we can do it again using the KCML and using the customize function of tilt. And we are saying that deploy anything that is there in your config samples folder. So we have one memcached object here, and I've just updated the tilt file, and I think we'll be able to see that resource. So that got deployed. So this is really handy that anytime you are making a change, it will continuously redeploy your samples here. In that way, you don't have to apply it again to test it. And there are ways to not, if you don't like that it gets redeployed by itself again and again, then there is a flag by which you can set it to false. That means it will only get triggered whenever you manually execute it. So we'll try to update this YAML. So there's a samples here in this example, which is saying that create this memcache CR with size 3 and container port this one. So we'll just now here we can see that the control got triggered and it's printing the size. Now if I change it here to 4, it got re-triggered. So you can see that how fast it is reapplying it, and your whole code is running inside your pod. So this is really helpful. And in the development phase, this time frame is very important, where whenever you make a change in your code, how long you'll have to wait. So with the help of that Docker build with restart command, that function in Tilt, it does this thing really fast. Like it just recreates your binary and just replaces it with the containers binary. Right. I think that's pretty much with the demo part. A few other things that I would like to cover in the slide is like you can also attach the debugger in your you can attach the debugger as a remote to your pod, and for that what you need to do is you can use Delve, and for that you need another Docker file. One more thing with Tilt is that if you don't like to manage multiple Docker file in your repo, what you can do is you can declare the Docker file inside your Tilt file itself. So here you can see that we are saying that create a Docker file with this set of steps, and use that at the time of build. So here you are saying that in Docker file, in the Docker build with restart command, you are saying that use that particular variable. So in that way, if you have a more Docker file that is only relevant with Tilt, you don't need to create those Docker files as part of your repo. You can just declare it as a variable inside your Tilt file. So using this Docker file and using updating the local resource for building the image and deploying it, what you can do is you can run your pod with Delve, and you will have to put forward it locally so that your editor such as VS Code or Golang, anyone you are using, you can connect that remotely to that Delve debugger. So this is a sample connection data that you need to connect with any remote debugging tool. So here you are saying that, okay, in VS Code, you are saying that, okay, connect with the container, which is running at 30,000 port. So in this way, you can attach debugger to your pod as well. So that's really handy. These are the resources, the default, the official Tilt documentation. This I would like to encourage you to look around the extensions, and extensions are nothing but a separate Tilt file. For example, all the things that we did right now are already there as an extension by name KubeBuilder. So if you look this extension KubeBuilder in the KubeBuilder Tilt file, you you'll see they are doing the, like, we took the inspiration from this file itself. So here you can see that there is a function called Q, kind of like manifest, generate, and all that stuff that we did right now. So instead of doing all the effort that we did right now, you can directly use this extension. But in case this extension doesn't works with you, then you can just take whatever commands that is available here and create your own Tiltfile. So extensions are a really nice place to look around a different possible way of deploying things in Tilt. So that's pretty much it from the demo part. If there are any questions, then it would be the right time to answer them. You can type question. If anyone has any question, they can type it in the chat. But yeah, like overall, there could be some challenges. For example, when I was trying it with Mac, I was facing some issue with the debugger part, the debugging part. But yeah, like there would be some trade-off, but like eventually it's really handy compared to deploying it using either Helm or any other way on your local environment. Plus, if you have multiple repos, for example, if you have dependency on any other repo, let's say you are managing controllers separately, then in that way you can use Tiltfile separately on the separate repos, and you can load it on your both of the Tiltfile, meaning that anytime you do tilt up on one of the repos, it will also tilt up the another repo for you. So it works really handy even if you have multiple set of repos and multiple Tiltfiles in that way. So I would encourage you to give it a try from my end. Yeah, we are almost, time is almost finished. So like if there are no other questions, then I would say thank you for attending this session and good luck.
Thank you so much, Tanveer. And yes, I don't see any other questions. So thank you so much for joining us today. Goodbye, everyone.